I have to study. Ignore the hair. I know it's raggedy. I don't know what else to do with it. So, I have some flashcards. I need to make more, though. What are these? What the fuck? What the fuck? Okay. Disaccharides are 2 sugars. So, like, things with 2 sugars in it. For example, sucrose, lactose, or maltose. Those are things with 2 sugars. Monosaccharides are things with 1 sugar. I know that because mono means 1. Simple sugars. Say, kind of the same thing. Like glucose, fructose, or galactose. Carbohydrates. Carbohydrates are main function is hydrogen, oxygen, and carbon dioxide, which are main functions of energy, or carbohydrates, hydrogen, and oxygen, which our main function is energy. Now, this is a memory aid for organic molecules. Can little people nap? Can little people nap? C for can is carbohydrates. L for little is lipids. P for protein is people, and nucleic acids is for N for nap. So these are all molecules that are organic. 4 major organic molecules. We already went over this. Do y'all remember it? I think it's going to be I know it's carbohydrates, lipids, it starts with a P, nucleids, proteins. I should remember that because I'm a gym girl. Proteins. I used to be a gym girl. Carbohydrates, lipids, proteins, and nucleic acids. Can little people walk? No, nap, not walk. I'm tired. I should remember nap. pH intensity. This is basically how intense the pH is. Every pH number represents a 10x difference in concentration. So basically, the concentration in the pH usually represents a 10x. pH basic. This is going to be exactly a 7. Never mind. pH basic is going to be greater than 7. pH scale neutral will be exactly 7. pH of 7. Correct. pH scale acidic is going to be anything less than 7. pH less than 7. Base. Now, this is very simple. Base is a substance that accepts hydrogen plus, H plus. This one's simple too. Acid. Acid is a substance that donates H plus. So the base accepts H plus. This gives H plus. This acid is giving base H plus. Acid is giving base H plus. They're BFFs right now, for real. Isotonic solution, which is like, isotonic is like, it's like, when it mixes, isotonic is like when it mixes, it's equal concentration. So when it mixes, it's equal amount. Hypotonic solution. Hypo means low. Low solution. I'm going to guess it doesn't mix together very well. Less concentrated. Yeah, so there's like think of lemon juice and water. So the other one would be half lemon juice, half water, equal, right? Equally concentrated. Less concentrated would be like way more water into the lemon juice. Okay, now hypertonic solution. Hyper solution. A lot more lemon juice, so more concentrated. See? Solvent. This is basically, think of water and salt. Solvent would be the water. Never mind. Actually, no, yeah, substance doing the dissolving, which is the water. Yeah. Now, to double check, we're going to check on solute. Substance being dissolved. The salt is being dissolved into the water. So, solvent, let's think of water. Solute, let's think of salt. Now, this is another memory aid. Let's look at the memory aid. Memory aid. Water function. I like hot tea. So I, as in ions, like as in lubricant, hot as in reactions, like hot, I don't know what the fuck I mean by that, honestly, sorry. And tea as for transportation. Water function, temperature, reactions, right? No, I'm wrong. Provides temperature regulation. So still temperature. It's regulating temperature. It's like hot and cold. Okay. Water function, transportation. This is gonna be, it moves through substance of the body. Maybe like osmosis, maybe? Probably, right? Water function, chemical reactions. This one's easy. It helps chemical reactions occur. So chemical reactions help chemical reactions occur. Water function, lubricant, like if you get your leg stuck in a pipe, you need to get butter to pull it out. You need to add some lubricant. It like makes things less friction, basically. Reduces friction between surfaces. Yeah. Water function, ions. Okay, this one's easy, guys. The water function ions allows ions in the solution. Now, the solution is the solvent and the solute together. This allows the ions in it. Electrolytes. Now, electrolytes are in like Gatorades and stuff. Okay, so ions dissolved in water. Now hold up. Now think of this. Electrolytes is something you can add to water or liquids, right? So they're adding electrolytes, which are being dissolved into water or Gatorade. We got this. Now, ions. What is an ion? We've been talking so much about ions. This is easy. It's a charged atom. What's an atom, though? It's like everything, like matter. Yeah. Ionic bond. This is a bond between ions. A bond where atoms gain or lose electrons. Electron is like the negative, like the minus number. A bond where atoms gain or lose electrons. That's an ionic bond. A covalent bond, I'm going to guess, is the opposite, where these ions are getting, not neutrons, but protons? No, I was wrong. A bond where atoms share electrons. And let me go to the last one we looked at. Okay. Let's look at this. It says a bond where atoms gain or lose electrons. That would be ionic bond. Now this one is a bond where atoms share electrons. This is a covalent bond. The difference between these is that two ions, which are basically charged atoms, two charged atoms are, this one's like two charged atoms are sharing electrons. Like they're together. This one is a charged atom that's like losing or gaining electrons. Radioisotopes. Now, radioisotopes, isotopes that give off radiation, like, you know, like how you catch cancer and shit, that's probably from an isotope that gives off radiation. Now, what is an isotope? We've been talking so much about these isotopes. Atoms with different numbers of neutrons. So neutrons is like the neutral like number, right? So atoms with different numbers of neutrons. That's basically atoms with different numbers of neutrons. So atoms, well, let's think about the periodic table of elements real quick. The first couple days I was like everyone else understanding where okay, sorry, my group chat of school was freaking out just like I am. Should I brush my hair? Atoms with different numbers of neutrons. Let's think of the periodic table of elements. I think like they all have different like neutrons, right? So like, yeah, that's an isotope. Now, the atomic mass is the sum, the atomic mass is the sum of the neutron and the proton. Oh, shit! The sum of protons and neutrons! We got that shit, dude! That's the atomic mass. We're adding the protons and the neutrons together. So think about the periodic table of elements, right? They got a neutron, electron, and they got a proton. We're adding the proton and a neutron together, and that's the atomic mass. Now let's look at the atomic number. Atomic number. I think that's going to have something to do with the neutron. Let's see. Number of protons in an atom. Okay, so I was wrong. And atomic number is how many protons are in that atom. Okay? Electron. Something I remember electrons is electron negative, proton positive, neutron neutral. So something negative. Let's see. A negative charge located outside the nucleus. So how we're going to correlate this? Electron negative. Electricity strikes your house. Lightning strikes your house. Everything's off. Everything's negative. Electron negative. Negative charge located outside the nucleus. Something else we can think about. That electrified bolt, the lightning hitting outside your house turns off all your power. That is this. The negative charge located outside the nucleus. The nucleus is our house. Neutron is neutral. Neutral charge. Neutral, zero charge, located in the nucleus. So our house, nucleus, right? The charge is normal. Everything's normal going on in the house. Nothing, it's neutral. Now proton, meaning like when you think about pros and cons. Pro, positive. Lights start to turn on in our house. It's a positive charge in the nucleus. The nucleus is our house. Now the elements. Now we are talking about the periodic table of elements. Fuck! I have to be at work in 10 minutes. Shit. Bye. But listen to this last one. Basic substances that cannot be broken down. So they cannot be dissolved, I'm guessing that's what it means. But yeah. Matter. Everything's made of matter. Anything that has mass and takes up space. Same thing. We got that. Okay. I have to go to work. But we did do some good studying. #later.